Welcome everyone. In this video, we are going to explore an important and fascinating topic: types of artificial intelligence, concepts, examples, and realities. Artificial intelligence is no longer just a future idea, it is already shaping the world around us. From smartphones and smart assistants to recommendation systems and automation, AI is everywhere. In this presentation, we will break down artificial intelligence into its different types, understand how each type works, look at real-world examples, and separate myths from reality. This video is designed to be beginner-friendly, so even if you are new to AI, you will be able to follow along easily. Let's begin this journey into the world of artificial intelligence. Before we dive deeper, let's take a look at what we will cover in this presentation. First, we will start with an introduction to artificial intelligence, where we will understand what AI is and why it matters. Next, we will explore narrow AI, which represents the present reality of artificial intelligence and is the most commonly used form today. After that, we will discuss general AI, the goal of creating machines with human-like intelligence. Then, we will move to super AI, which represents the future vision of intelligence that goes beyond human capabilities. Finally, we will examine the real-world status of AI and clear common myths by comparing expectations with reality. This structured approach will help you understand AI clearly, step by step. This slide once again highlights the roadmap of our discussion. Each section builds upon the previous one, starting from basic concepts and gradually moving toward advanced ideas. By the end of this video, you will not only understand the different types of artificial intelligence, but also develop realistic expectations about what AI can and cannot do today. Let's now begin with the first section, Introduction to Artificial Intelligence. Let's start by understanding what artificial intelligence really means. Artificial intelligence refers to machines or computer systems that simulate human intelligence to perform tasks autonomously. These tasks include learning from data, reasoning, problem-solving, understanding language, and making decisions. AI plays a crucial role in modern technology. It drives innovation by increasing efficiency, reducing human effort, and enabling smart decision-making across digital systems. The development of artificial intelligence began in the 1950s and has evolved over time through major milestones such as machine learning and deep learning. Today, AI has a powerful impact on various industries. In healthcare, it helps with diagnostics and treatment planning. In finance, it assists in fraud detection and risk analysis. In manufacturing, it automates complex processes and improves productivity. Overall, artificial intelligence is transforming the way we live, work, and interact with technology. Now let's look at how artificial intelligence is classified based on its capabilities. Broadly, AI can be divided into three main types: narrow AI, general AI, and super AI. First, narrow AI, also known as weak AI. This type of AI focuses on performing specific tasks under limited conditions. It is designed to assist humans or take over well-defined tasks efficiently. Narrow AI does not possess true understanding or consciousness, and it cannot operate beyond its assigned domain. Most of the AI systems we use today, such as virtual assistants, recommendation systems, and image recognition tools, fall under this category. Next, general AI, also known as strong AI. General AI refers to systems that possess human-like cognitive abilities. These systems would be capable of understanding, learning, and reasoning across multiple domains, just like a human. Unlike narrow AI, general AI can transfer knowledge from one domain to another. However, it is important to note that general AI does not yet exist in the real world and remains a long-term research goal. Finally, super AI, or artificial superintelligence. Super AI goes beyond human intelligence in every aspect, including creativity, problem-solving, and decision-making. Such systems would be capable of self-improvement and advanced reasoning at levels far greater than humans. At present, super AI is purely theoretical and exists only as a future vision. Understanding the different types of artificial intelligence is extremely important for both beginners and professionals. First, it helps beginners and experts grasp fundamental AI concepts clearly and effectively. When you know the difference between narrow AI, general AI, and super AI, it becomes easier to understand how current technologies actually work. Second, understanding AI types helps in avoiding common misconceptions. Many people believe that today's AI systems think or feel like humans. In reality, most AI systems are task-specific and operate based on data and algorithms. Clear knowledge prevents false beliefs and sets realistic expectations about AI capabilities. Finally, understanding AI types has practical implications in both life and work. It helps individuals and organizations apply AI technologies efficiently in everyday tasks and professional environments. Whether you are a student, developer, or business professional, this knowledge allows you to use AI responsibly and effectively. Overall, knowing AI types empowers you to separate hype from reality and make informed decisions about technology. We now move to the second section of this presentation, Narrow AI, the present reality. This section focuses on the type of artificial intelligence that is most widely used today. When people talk about AI in daily life, they are usually referring to narrow AI. Narrow AI is designed to perform specific tasks efficiently within a limited scope. Although it can appear intelligent, it does not possess true understanding or human-like reasoning. In the next few slides, we will explore what narrow AI is, its key characteristics, its strengths and limitations, and how it is applied in real-world systems such as virtual assistants, recommendation engines, and image recognition tools. Let's dive deeper into how narrow AI works and why it represents the present reality of artificial intelligence. Narrow AI, also known as weak AI, refers to artificial intelligence systems that are designed to perform specific and well-defined tasks with high efficiency and accuracy. Unlike humans, narrow AI does not possess general intelligence or consciousness. The first key characteristic of narrow AI is specialized task focus. These systems are built to excel at one particular job, such as face recognition, language translation, spam filtering, or voice assistance. Because they focus on a single task, they can often outperform humans in speed and precision within that limited area. The second characteristic is limited scope intelligence. Narrow AI operates strictly within a restricted domain. It cannot transfer its knowledge or skills to unrelated tasks. For example, an AI that can recognize images cannot automatically understand human emotions or write poetry unless it is specifically trained for those purposes. The third important characteristic is program-specific functions. Narrow AI systems are explicitly programmed or trained using data for particular functions. They follow predefined rules, models, or learned patterns, rather than adapting broadly like human intelligence. In summary, narrow AI is powerful, efficient, and highly specialized, but it lacks general reasoning, creativity, and self-awareness. This makes it ideal for practical applications, yet fundamentally different from human intelligence. To better understand narrow AI, let's look at some real-world examples that we interact with almost every day. The first example is virtual assistants. Tools like voice assistants can understand spoken commands, answer questions, set reminders, or control smart devices. However, their intelligence is limited to specific tasks such as speech recognition and predefined responses. They do not truly understand conversations the way humans do. The second example is recommendation systems. Platforms like video streaming services, online shopping websites, and music apps use narrow AI to analyze user behavior. Based on past searches, views, or purchases, these systems suggest content or products that match individual preferences. While highly effective, they cannot think independently beyond the data they are trained on. The third example is image recognition software. This type of narrow AI is used in facial recognition, medical imaging, and security systems. It can accurately identify objects, faces, or patterns in images, often with better precision than humans. However, it cannot understand context or meaning beyond visual patterns. These examples show how narrow AI is deeply integrated into modern life, efficient, reliable, and task-focused, yet limited in scope. Now let's understand the advantages and limitations of narrow AI, to set realistic expectations about what it can and cannot do. First, let's talk about the key strengths of narrow AI. Narrow AI is extremely efficient at performing specific tasks. It can process large amounts of data quickly, deliver high accuracy, and operate continuously without fatigue. Because of this, it is also cost-effective and widely used in industries such as healthcare, finance, and e-commerce. Next, we have the main weaknesses of narrow AI. Despite its impressive performance, narrow AI does not possess true understanding, awareness, or consciousness. It cannot think creatively, adapt freely, or apply knowledge outside its predefined domain. Its intelligence is limited to patterns and rules learned from data. Finally, let's focus on realistic expectations. Narrow AI is powerful when used for clearly defined problems and structured environments. However, it cannot replicate human-level general intelligence or emotional understanding. Recognizing these limits helps us use AI responsibly and effectively. In short, narrow AI excels in specific areas, but it remains a tool, not a replacement for human intelligence. We now move to the next section, general AI, The goal of human-like intelligence. This section focuses on the idea of creating machines that can think, learn, and reason in a way similar to humans. Unlike narrow AI, which is limited to specific tasks, general AI aims to understand and perform a wide range of tasks across different domains. General AI represents a major goal of artificial intelligence research. It seeks to build systems that can apply knowledge flexibly, solve unfamiliar problems, and adapt to new situations without being explicitly programmed for every task. In the upcoming slide, we will explore what general AI is, how it differs from narrow AI, and why it remains a powerful yet challenging objective in the field of artificial intelligence. General artificial intelligence, often called strong AI, refers to a type of AI that possesses human-level cognitive abilities. This means the AI would be capable of thinking, reasoning, and making decisions in a wide variety of situations, just like a human being. One of the most important features of general AI is broad learning and understanding. A general AI system would be able to learn from experience, understand concepts deeply, and apply its knowledge across multiple domains. For example, it could learn mathematics, understand language, solve real-world problems, and adapt to new environments without being specifically trained for each task. Another key point is the difference between general AI and narrow AI. Unlike narrow AI, which is limited to specific tasks and datasets, general AI would not be restricted to one domain. It could transfer knowledge from one area to another and handle unfamiliar problems intelligently. At present, general AI does not exist in the real world. It remains a long-term research goal, representing a significant leap toward human-like intelligence in machines. Although general AI is a powerful and exciting goal, achieving it comes with significant challenges. The first challenge is the complexity of human intelligence. Human intelligence involves not just logical thinking, but also emotions, creativity, intuition, and social understanding. Replicating all these cognitive processes in a machine is extremely difficult, as the human brain itself is still not fully understood. The second challenge is computational power requirements. General AI would require vast amounts of data, memory, and processing power to operate at human-level intelligence. Current hardware and energy resources are not yet sufficient to support such advanced systems on a large scale. The third challenge involves ethical and control issues. As AI systems become more powerful, ensuring their safe and responsible use becomes critical. There are concerns about misuse, loss of human control, and unintended consequences. Strong governance, ethical frameworks, and safety mechanisms are essential before general AI can become a reality. These challenges explain why general AI remains a research goal rather than a present-day technology. Let's now look at the current research and theoretical progress in artificial intelligence. The first aspect is the key milestones timeline. AI research has evolved over several decades, starting from early rule-based systems to modern machine learning and deep learning models. Each milestone has contributed to increasing the capabilities of AI, shaping how intelligent systems are designed and applied today. Next, we have notable projects and breakthroughs. Several landmark AI projects have demonstrated significant advances in areas such as machine learning, natural language processing, and cognitive computing. These breakthroughs have enabled machines to recognize images, understand language, and learn from experience more effectively than ever before. Finally, let's discuss future development predictions. Experts predict rapid advancements in AI research, driven by improved algorithms, larger datasets, and more powerful computing resources. Many researchers believe these developments could gradually move AI closer to human-like intelligence in the future. Overall, current research shows strong progress, but achieving truly human-level AI remains a complex and long-term challenge. We now move to the next section, Super AI, the Future Vision. This section explores the idea of artificial intelligence that goes beyond human intelligence. Super AI represents a hypothetical stage where machines not only match human abilities, but significantly surpass them in every field. In the upcoming slides, we will discuss what Super AI is, its potential capabilities, the benefits it could bring to humanity, and the serious risks and challenges it may pose. Understanding Super AI helps us think critically about the future of technology, ethical responsibility, and how humans and intelligent machines might coexist. Let's now explore this future vision of artificial intelligence. Super artificial intelligence, often referred to as Super AI, represents a level of intelligence that goes beyond human capabilities. The first defining feature of Super AI is surpassing human intelligence. This means the AI would exceed human abilities in all cognitive and functional domains, including reasoning, learning, creativity, and problem-solving. At this level, machines would be able to make decisions far more efficiently and accurately than humans. The second feature is self-improvement and creativity. Super AI would have the potential to continuously improve itself without human intervention. It could generate innovative ideas, discover new knowledge, and solve complex problems in ways humans may not even imagine. The third and most important point is that super AI is hypothetical and speculative. At present, such intelligence does not exist in the real world. It remains a theoretical concept that is actively debated by researchers, technologists, and philosophers. In summary, super AI represents an ambitious and uncertain future, raising both excitement and serious concerns about the direction of artificial intelligence. Super artificial intelligence has the potential to bring extraordinary benefits, but it also presents serious risks that must be carefully considered. Let's first look at the potential benefits of super AI. Super AI could help solve major global challenges such as climate change, disease prevention, and resource optimization. It could accelerate scientific research, drive innovation, and significantly improve efficiency across industries like healthcare, energy, education, and space exploration. With intelligence beyond human limits, super AI could unlock solutions that are currently impossible for humans alone. However, alongside these benefits come significant risks. One major concern is the potential loss of human control over highly intelligent systems. As super AI becomes more autonomous, ensuring alignment with human values becomes increasingly complex. There are also serious ethical dilemmas, including decision-making authority, accountability, and the impact on society. In extreme scenarios, poorly controlled super AI could pose existential threats that might endanger humanity's future. For these reasons, the development of super AI requires cautious research, strong ethical frameworks, and global cooperation to ensure safety and responsibility. The idea of super artificial intelligence has sparked intense debate among experts around the world. One major point of discussion is expert opinions on its arrival. Some researchers believe super AI could emerge within a few decades, while others argue it may take centuries, or may never happen at all. These differing views reflect the uncertainty surrounding the pace of technological progress. Another key debate involves technological and philosophical gaps. From a technological perspective, we still lack the systems, algorithms, and understanding needed to create intelligence beyond human levels. Philosophically, questions remain about consciousness, free will, and whether true intelligence can even be replicated artificially. The final consideration is the impact of regulation and safety. Strong safety measures, ethical guidelines, and global regulations could significantly influence how and when super AI is developed. Some argue that strict regulation may slow innovation, while others believe it is essential to prevent catastrophic outcomes. Overall, the feasibility of super AI remains uncertain, making careful debate and responsible research more important than ever. We now move to the final section of this presentation, real-world AI status and myths versus reality. In this section, we will take a realistic look at where artificial intelligence stands today. While AI is often portrayed as highly intelligent or even human-like, the reality is very different. We will address common myths surrounding artificial intelligence and compare them with what AI can actually do in the real world. By the end of this section, you will have a clear and balanced understanding of AI, free from exaggeration and misconceptions. Let's separate facts from fiction and explore the true state of artificial intelligence today. Artificial intelligence is actively transforming multiple industries in the real world today. In healthcare, AI assists in disease detection, medical imaging analysis, personalized treatment, and drug discovery. In the automotive industry, AI powers self-driving technologies, advanced driver assistance systems, and intelligent traffic management. In finance and analytics, AI is used for fraud detection, risk assessment, algorithmic trading, and personalized financial services. In education, AI enables adaptive learning platforms, automated grading, and personalized educational experiences. Through automation and analytics, AI optimizes business processes, improves productivity, and supports data-driven decision-making. Finally, in terms of societal and job impact, AI reshapes the workforce by automating routine tasks while creating new roles that require advanced skills. There are many misconceptions about artificial intelligence that often create unnecessary fear or unrealistic expectations. The first myth is the AI consciousness myth. AI does not possess emotions, self-awareness, or consciousness. It only processes data and follows algorithms created by humans. The second myth is the fear of complete job replacement. While AI can automate repetitive tasks, it also creates new job opportunities and works best when combined with human skills rather than replacing humans entirely. The third myth is the illusion of unbiased AI. AI systems can reflect biases present in the data they are trained on, making human oversight essential to ensure fairness and ethical use. By debunking these myths, we gain a more accurate understanding of what AI truly is: a powerful tool, not an independent or flawless intelligence. Despite rapid advancements, it is important to understand what artificial intelligence can and cannot do today. First, let's look at current AI limitations. AI systems lack true understanding, emotions, and common sense, and they depend heavily on data quality and predefined models to function effectively. Second, human oversight remains essential. AI cannot operate responsibly without human supervision, as humans are required to set goals, interpret results, handle ethical decisions, and correct errors. Finally, consider AI's evolution and progress. AI continues to improve rapidly through advances in machine learning, computing power, and data availability, but it is still far from achieving human-level or superintelligence. This reality check helps us appreciate AI's capabilities while recognizing its boundaries, enabling smarter and more responsible use of the technology. Thank you for watching, and I hope this video helped you gain a deeper and more realistic understanding of artificial intelligence. If you found this video helpful, make sure to like it, share it with your friends, and subscribe to the channel for more insightful tech and AI content. Also, press the bell icon so you never miss an update. See you in the next video.